Hello, today we're going to work on LeetCode number 1, to sum. It's an easy problem. So in this problem, we're given an array. The example here is 2, 7, 11, 15 in the array, and then also a target. In this case, it's 9. And we want to see if any two numbers in the array add up together to target of 9. So I think probably the first solution that might pop into your head is, well, let's just take every two possible combinations of these numbers in the array, like 2, 7, 2, 11, 2, 15, etc., and add them together and see if they equal 9, and just check each combination. And I think that's a fairly simple, easy to understand solution. And so that might look something like this. So let's see. This is going to be our brute force, right? And it's going to be something like this, just for sake of illustration. So basically, we're going to iterate through the index I in the array, and then we're going to look at the second number, which is going to start from I plus 1. So that's going to basically be like I is going to be 0, 1, 2, 3. And so you'd want to compare the next number, so I plus 1 in this case, 7, 11, 15, right? And then if your I is your first number 7, then your j would iterate through 11, 15, etc. So x range, I plus 1 to len nums. And then you would do if nums I plus nums j, these are the two numbers you're comparing, they're equal to the target, then return I, j, array. And if you get to the end of your iteration and can't find anything, then you're going to basically return an empty string, or empty array. So let's just go ahead and try this one out and see if it works. All right, so it looks like it's basically working. So for this solution, I think it's pretty easy to understand. But basically, like we were saying, I is going to iterate through here, right? And then j will iterate from each number after it. So you get 2, 7, 2, 11, 2, 15. And so if you think about this, basically you're going to check each number against every other number after it. Ends up being n squared time in terms of time. So time complexity is going to be n squared. If you don't believe me, leave a comment and I can make a follow-up video on why this would be n squared. And then also space complexity, in this case, we're doing everything in place, so that's going to be 1, or constant spaced. So this is the brute force solution. So the n squared time is probably not the most ideal in this case, and so let's look and see if we can find a more optimal solution. So if we think about it, a lot of times for these array problems, you can actually trade off space and improve your time complexity by using some other external data structure. So that would be a trade-off of your space complexity for time complexity. So let's comment this guy out, and let's think of another solution. So the next solution we can think about is basically, what if as we iterate through this, we want to just keep track of everything we've seen before. And we'd want to do that in a, if we're iterating through this one time already all the way through, that's already going to be n checks. And then each check, if we have to check n more things, it would end up being n squared again. So we have to find a way to check if each number has a pair that matches this target, and do that in constant time, or just a time that is better than n time. In this case, I think let's move. As I explained in part of the solution, you'll see that it actually that check is going to be constant time. So basically, how this would work is you would basically set up a hash. So in this case, I'm just going to call it lib. So this is a Python dictionary. It's got a constant time access. You can check if a key is in this library in constant time. So what we could do is basically for right. So we're going to iterate through the nums array, and we're going to get the index and the number itself. And then each time we go through here, we're going to basically put in into our library what would be the number that would be the complement to this number that would give us the solution we want. So for example, the target is 9, for example. So the first number we see is 2. So with 2, we want to find a 7 to match it, right? Because 2 plus 7 is 9. So how do we get that other number? So in that case, it would be the target minus the current number. So target minus the current number. So that's going to be the key of your hash. And then your value is going to be the index, because that's what we need to return. So let's do it like this. If your current number, in this case 2, is in the library, then we can go ahead and return lib of n, and then I. And so basically what this is saying is, if this number is in the library, that means the index of the complement is at that point. So that's what this is, and then this is your current index. And we'd go ahead and do that return. If it's not found, then we just put this into the library, and then as we iterate through, we can check against it. And so if this iterates all the way through and nothing is found, and we don't enter this part, then we would basically just return an empty array. So I'll go ahead and run that. Let's just make sure it works. All right, and it works. In an actual interview, it also might be, maybe the interviewer might also ask you just to do some corner cases. So maybe let's just walk through this example. What happens if we give it, let's say, an empty target nums array, right? Okay, so in that case, we would not iterate through, we would just return the empty, so that's fine, that works. So let's see here, so let's just mark some of this stuff down. What if they give you the empty nums is empty, right? Doesn't really matter what target is in this case. It was just going to return an empty, right? That's the only thing I could return. What if you were given nums with just one thing in it? What would return? And this should return an empty as well, because there's not two numbers. So let's just see. It would go through this once. There's nothing in the library, so it could not enter here. Then it would put the complement of this into the library and then return empty, so that returns empty as well. So I think that also works. And yeah, I think this works. So let's just go ahead and submit, just to make sure. All right, and it's in. And this one, let's just quickly talk about the complexity here as well. This is going to be a n time in terms of time, because what happens is you go through the array one time, you iterate through once, and each of these operations down here are constant time operations. I think the thing that's most interesting, I guess, is to say like, hey, this check, if n in lib, checking a key into the Python dictionary, the library, is that is a constant time. That's just a feature of the hash or the dictionary data structure. And in terms of space, since we have to fill this guy out, the library, as we go through, each time you have a check that is unsuccessful, you have to go into the library. So and you keep on putting one more item into the library, one more item into the library. So this actually ends up, at a worst case possible situation, it could actually be, it's going to fill up with the whole array. So that's going to be a space complexity of n time, or n space as well. So for this solution, you're trading, compared to our earlier brute force solution, right? The time previously was n squared and space was constant time. Now we have, the time is now n and the space is now n. So we basically have worse space complexity, better time complexity. A lot of times in the interview, the more advanced or difficult solution is generally going to be something that is more efficient in terms of time. So this is the solution that they probably would be looking for. But I think it's also valuable to understand the time and space complexity and be able to discuss like the trade-off here, why this solution is better, right? We're trading off this, the space complexity for better time complexity. Cool, and so that's your solution. This is that's the solution for this one. So best of luck.